Hello and welcome. My name is Huba Benzar. My dissertation title is Procedurally Generated Game. This project aims to create a procedurally generated game for desktop which increases in difficulty over time. Procedural generation is a method of creating algorithmic data to create content. As someone who has a large passion for video games, I know that there is no worse feeling than completing a video game you love. Minecraft and Call of Duty Zombies have kept me occupied for years. Zombies challenges players to survive longer each playthrough, while Minecraft has an infinitely generated world that allows players to carry out missions they set themselves. The common denominator in these games is that each time players start a game they can control the environment by using seeds or hand-built maps. Zombies has a lack of maps which hinder its replayability, while Minecraft has a seemingly infinite number of worlds which are all different. Infinite of course stopping at the limits of technology. However, they can still create a world 7 times larger than Earth. My motivation was to create a game that is both thrilling to play and has an abundance of content for people to enjoy for a long time. Breaking this down into simple aims and objectives, firstly I had to create a game that utilizes procedural generation, which I have implemented in a nearly perfect way. The terrain and water generation is seamless, while object placement needs further improvement as sometimes objects spawn on the ground. If I had more time I would have fixed this bug, but it didn't hinder the playability of the game, therefore I focused on more pressing matters. The second aim would be to increase the difficulty of the game over time. The player has to collect mysterious artifacts that crash into Valhalla to increase the amount of time they survive. The more artifacts the player collects, the less time is added on. The game allows the player 3 minutes to collect their first artifact, after which 115.8 seconds are added onto the timer. The timer reduces until artifact 24 when it bottoms out, adding on 20 seconds, after which the increasing difficulty is the concentration span of the player. 20 seconds is simply not enough to collect artifacts without a strategy that requires a lot of planning, combined with the non-stop action of the game tires a person out mentally. Please have a look at the table where I listed the times added on. The objectives are color-coded based on implementation stage. The game tracks players' statistics in the form of playtime, artifacts collected, and time left. The game has the ability to create multiple traversable worlds. However, due to a lack of time, I decided to focus on more important tasks and merge all of it into one infinite level. I decided to implement and remove the ability to save the game, as the gameplay complements a single life to get as far as possible, just like in Call of Duty Zombies, really well. I added extra objectives during development, and I've indicated this on the slides in the middle column. I implemented the world generator, which I later made infinite using Perl and noise and with the use of seeding. Implementing seeding allows for seamless world generation, as the chunk next to the player will be generated according to the seed parameters. Adding these chunks to the list allowed for loading and unloading the chunk. I also added the same thing for water and object generation, where a given seed generates the world the exact same way every single time. Added collision and the player controller, making sure that my world generation was smooth and players cannot get stuck in places. Implemented the escape key so the players can exit the game whenever they feel like it, in a way that doesn't corrupt the game, as the game will have time to finish its executions. Implemented universal render pipeline instead of the standard Unity render pipeline, as it allowed for development for multiple platforms. Although not fully tested, the game should work on all platforms, especially one with keyboard and mouse implemented. A huge oversight I had for my objectives was not to list a start and end to the game. It felt so natural that I didn't include it. Once implemented, it made the game feel whole. There is a title, menu, game, and end screen. The game has gradual difficulty change, as the player will have less time to reach the next artifact based on the amount they collected. I partially implemented object placement, as the game does place the objects, but as stated before, it needs further improvement. However, the objects are guaranteed not to spawn on the player, making sure that the game does not get soft locked. I partially also implemented traversable world generation in the form of infinite worlds instead of teleporting the players from one level to another. It places chunks next to each other infinitely, just like in Minecraft. As I got rid of the implementation for players to save the game, it also got rid of the need to load the game. However, I would have liked the ability to implement a menu that can change the game and remember the save. Due to time constraints, I decided to focus on other things. To balance the game better, I decided to remove difficulty options, making the game the same difficulty for everyone. Players will have to learn strategies to get further, but everyone starts in the same place. I decided to do this based on my research and feedback. All players unanimously agreed that the timer was fair to be the same for everyone, similarly to Call of Duty Zombies. I did not manage to implement a leveling system or enemies into the game, as on further research this would have been hard to implement, as creating leveling systems that is balanced is hard, especially if it is infinite. This would have come with a need to create an AI system that would be capable of scaling with the experience system that increases in difficulty over time. Designing enemies that are not repetitive with multiple damage points in their body would have been hard to create, and I do not think I have the experience to create such a system. Therefore, I proceeded to create a game in a collection manner rather than leveling, as it still creates an intense environment for the player. Feedback from testers also resulted in a similar feel, as players would rather run around collecting objects rather than fighting enemies that are incapable of engaging fights. This slide shows my Gantt chart. I tried my best to follow it and only had minor adjustments as complications arose. The problems I encountered while developing my game was a lack of knowledge of C#. This gave a lot of code to change over time. Another problem I had was time management at sections of my project. Crafting the main menu, as my initial idea was to create functions that work around the world and implement it in the game. It gave me a good experience and visualized what I wanted in my game. I will show the progress of the main menu on the next slide. Converting my project over to Universal Render Pipeline, or URP, from standard pipeline meant that I had to rework a lot of my code and change my assets. On the left is my first menu, and on the right is my final outcome. If I had more time, I would have loved to implement a plethora of features, as the project was a lot of fun to work on. From my software design and implementation, I discovered that creating the procedurally generated game that is perfectly coherent requires a lot of technical knowledge and a strong game engine. I try to optimize as much as possible. The main menu of my game is what I aim my game to look like in the final version, or at least very close to. Thank you for listening. On your screen right now is my development environment for my project in Unity. Once the game is loaded, it takes the user to the Valhalla splash screen. The purpose of this is to allow for the assets to load, making the game smoother. The main menu is handcrafted in a way to mimic the outcome of the game that was meant to be like. I feel that the day-night cycle and the animation environment reflecting water bring the game alive. The vegetation and buildings you see on the screen are all modified Unity assets. While on the menu screen, the player has 4 options to choose from: Start, Help, Advanced Settings and Quit. The quit button simply exits the game when pressed. Advanced settings allow the user to enter the seed that will initiate the pseudo-random number generator. This guarantees that the generation will be carried out the same way every time. If the seed is empty, a random seed will be generated automatically. I will further break this down later, as I'm very proud of the code. Here you can see me enter the seed Love, which will generate the same world as shown. The help menu gives brief overview of the game and controls. The start button initializes the game and places the player in the game environment. The seed is based on the string entered, otherwise the seed is randomly generated, similarly to the advanced settings being empty. Once in the game, the player is spawned just above the terrain and has information fed to them in the HUD. The HUD is animated, slowly fading from the beginning to be a bit darker. It consists of seed information in the top left and escape to return. Bottom left has the artifact count, and the bottom right has the time left, which changes when different time limits are hit. Red being 10 seconds left and 30 is orange, otherwise the text is white. The player also has a crosshair to know where the middle of the screen is. The objects and player controller used were purchased from the Unity store in order to improve the visuals of the game, as well as to give the Valhalla or Viking era setting. The game is not the same throughout, as in the intercardinal directions more objects generate, allowing for discovery and strategy planning. As you can see, the water perfectly reflects the environment, including the sun and the moon. The day and night cycle add a strong dynamic to the game, as it shows the environment changing around the player. Initially, the player has 3 minutes to collect their first artifact, upon which time is added according to the number of artifacts collected, as discussed in the slides. If the player has no strategy, it will take approximately 40 seconds to reach the next artifact. This means that reaching higher collection numbers will have a barrier for players, which will require them to improve their thinking. To show the level of optimization for my game, I will be flying over it at high speeds to show how quickly it loads and it doesn't stutter. While this is showing, I would like to talk about the ending screen. Once the timer runs out, the player will be shown the ending screen. This is where the player will be informed that the game is over and will show their statistic, the time they survived and the number of artifacts they gathered, allowing for friendly challenges with friends. Players can replay the same level to improve on their time or pathing. When the player presses the button, the game quits. I am most proud of my seed generation and the use of Perl and noise. My seed generation, when the game starts, it sets a random string. If the input is empty, it generates a fresh string which would be found in the advanced setting. This converts the string into a hash code that is always the exact same. If the start button is clicked, it uses the inserted or randomized string. The text is also updated on the screen to show players. This code is really compact and made me really happy to produce it. The second piece of work I'm really proud of is my Perl and noise generator. This was the first large piece of advancement I've made, and I was really happy about it. It firstly initializes the seed, inserted, then cycles through the settings and noise settings that are edited in the Unity editor to gather values. On screen are the settings I found best. Scale is responsible for the size of the 2D noise map. Octaves is the number of seed layers we want to overlay, which exponentially decrease in effect with increasing numbers. This is controlled by the persistence. Lacuranity is how fractals fill space. When patterns have more or large gap, generally have higher lacuranity. Offset moves the noise map in a direction. Height map and curves are the things responsible for raising the noise from its default height, which is nothing, 2. A 3D map, which is generated using the height map generator I created. The XYZ coordinates from the 2D noise map are generated. The darker the noise, the closer to 1 it is, meaning the higher on the y-axis. As it's pseudo-random, it's logical and natural looking, which is perfect for terrain generation. Thank you for listening to my demonstration.